Welcome to MOOC on Statistical Methods for Psychological Research 2. In this module of today, we are going to discuss about hypothesis testing for difference among 3 or more groups. In this part, we are going to discuss about two-way parametric tests and non-parametric hypothesis, in which more than 2 groups is our concern. Two-way ANOVA description with example, if you observe, for example, consider a company sells 3 items, say swimming pools, spas and saunas. The owner decides to see whether the age of the sales representative and the type of item affects monthly sales or not. So, if you see that this is the data which deals with dependent variable is monthly sales. Monthly sales, that age of the salesperson, there are over 30 years and under or equal to 30 years salespersons. There are 2 categories about the age of salesperson and there are 3 categories of the customers. So, the variables under study, the dependent variable is considered to be the effect, that is monthly sales. Monthly sales is the dependent variable, response variable is the monthly sales. Then causing or factor variables are, one is age of the salesperson, another is the categories of the product. So, we use it to test at alpha 5% level of significance whether there is any significant difference between the average sales between the categories, that swimming pool, spa and sauce. And another one is hypothesis is to test whether there is any significant difference between age groups of the salespersons on average sales. This is what our interest to study. So, there are 2 ways, one way is the categories, another is age of the salespersons. So, differences if you observe, there is no significant, the statements H naught is that alternate null hypothesis is that there is no significant difference between the means of monthly sales with respect to age group of the salespersons, and alternative hypothesis is there is significant difference between the means of the monthly sales with respect to the age groups of the salespersons. So, if you observe this data, it is something like your comparison is in between there is any difference. This is difference between row headings. Now, coming to the next item, the column headings you want to verify whether there is any significant difference. What is the null hypothesis is there is no significant difference between the means of monthly sales with respect to the type of the product. And similarly, alternative hypothesis is that the monthly sales, there is no significant difference between the average monthly sales regarding the type of the product. Now, if you observe this data, here our comparison is there any significant difference between the columns? The previous one is the rows. Now, another comparison is interaction between row headings. This one you have to compare both the significant difference between whether the H naught says that there is no significant difference between the average sales between the age groups and the product sold, that is null hypothesis, and H1 is there is a significant difference. Now, coming to the data set, if you see that this is a 2-dimensional classification we are making, both together if you are doing, it is called joint or interaction effect. So, this way 3 categories we are making for two-way analysis. So, when you see this data, it is first one you are claiming that this is the data for related to over 30 years when the age of salesperson is this one. When the age of salesperson is less than or equal to, these are the data. So, here we have sum of squares, degrees of freedom, you can conclude that the null hypothesis is rejected. Null hypothesis rejected. What is the null hypothesis? Null hypothesis says that there is no significant difference between the average sales, that is the null hypothesis. And in this context, the columns have no significant difference. What it means that there is no significant difference between the average sales between the categories or product types, except that hypothesis. Remaining two hypotheses are accepted. So, therefore, the conclusion if you want to make, that is the way you have to give the conclusion. And numerical example, if you see that for a groups of students, this is the data, there are 4 groups of students. Assume that their achievement test scores, these are all called scores. Students are 4 groups are there, first group 1, 2, 3, 4, second, third and fourth groups also equally numbered. So, in this case we want to go for the comparison part, computation methods. The hypothesis says that distribution scores are the same, null hypothesis. Alternative says that distributions are differed. So, this is the test statistic formula just now we have considered. If you see this data, you can say that in the total data, what is the least observation will be the first rank, what is the highest observation will be the greatest rank. If you see this total thing 65, 75, 59, 94 and all these things, 59 again is that within brackets, that is rank 1 and rank 2 means next highest, then rank 3 will be the next highest and so on. If you say that all these 4 4 means 16 to be ranked in such a way that all the observations. Find the totals of the first column, first group, second group, third group, fourth group, 31, 35, 15, 55 are the totals. So, you have to see the T1 is 31, 31 square, T2 is 35, 35 square, T3 is 15, 15 square, T4 55, so that 55 square. So, this formula says that this square by n or all n's are equal, 4, 4, 4, 4, therefore, 4 is common. So, 12 by n is 16 observations are there, sample size. So, this is the formula on simplification, the test statistic is 8.96. So, after calculation that you can find the p value and this p value can be considered as if it is less than 0.05 then H0 is accepted, otherwise rejected. So, you have to conclude here that the test statistic degrees of freedom, it is the critical value is 7.81 and 8.96 is the test critical value. Since test critical value is more than the test statistic value is more than test critical value, H0 is rejected. So, therefore, H0 is rejected. What it means? There are all the groups have equal distributions, that is rejected. That rejected, what it means that there is no significant difference, there is a significant difference between different distributions. This is what in Kruskal-Wallis test we consider. Okay, in part 3 we considered two-way parametric and non-parametric hypotheses, which we discussed with numerical examples, parametric with two-way analysis, non-parametric with Kruskal-Wallis. Overall, in this module, in part 1 we have discussed about the conceptual understanding of parametric hypothesis and non-parametric hypothesis for more than 3 groups, and in part 2 we considered about one-way analysis, its theory and its application with numerical examples. In part 3, in two-way parametric and non-parametric hypothesis using the numerical examples, so that you can have how to make use of this hypothesis testing for more than 2 groups is completed. Thank you.